It's doing recording and transcription. Is that okay?
Yeah, that's perfect. If
Okay.
you want to stop the transcription, it's fine as well.
Okay.
Okay, so welcome everyone. Welcome to this information session on HPAI. So my name is Manon Rasco. I'm a vet epidemiologist with the CFIA. I'm part of the science branch. I've been involved into this HPAI event since 2022. So what we have tried to do today is summarize a little bit all the findings so far. And I'm also with my colleague, Mandy. Do you want to introduce yourself?
Sure. Yep. I'm Dr. Amanda Emery. I go by Mandy for the most part. I'm a veterinarian in the Fraser Valley, Lower Mainland of BC. And I work in the policy and programs branch of CFIA and was involved mostly in the Western Canadian response for HPAI in the various waves in various roles and capacities, wherever I was needed at the time. Thanks.
Excellent. So can you see my screen and can you hear me well? It's all good? Perfect. So as we mentioned, the meeting will be recorded for those that cannot make it today. If you want to share the link after the meeting, it's fine. I'll be also sharing with the PDF of the presentation so you can have the visual as well. So today, the idea is to present an update on HPAI and on outbreak investigations for waves 1 to 3. So that will be covering the infected premises between December 2021 and September 2023. So we're currently finalizing the fall migration cases. The last fall, so wave 4, we're getting to the end, so we'll have more to share eventually. And for wave 5, there was only one infected premises in Quebec. It was a backyard flock. So far, it's the only one we have seen across the country. So it's good that it's slowing down. It's giving us all a break of HPAI in domestic birds. So what I'll be covering today is the different incursions of the virus into the country. I'll be giving an update on the detections in wild birds, mammal, domestic birds. I'll be also touching based on where Canada is at in the international level, like in terms of number of outbreaks. And the main focus of the presentation is to go through the outbreak investigations to see if the farms were connected, what's the likely route of introductions, and what are the potential risk factors. I'll be finishing up with lessons learned and some research projects that are currently ongoing for HPAI. So let's start with the incursions of the virus into the country. So as you know, the virus was first detected in Newfoundland, Labrador in 2021, late November, late 2021. It was an H5N1 that was fully Eurasian lineage. And then we have seen this virus moving across the country, doing reassortments with low-path AI that was already present in the wild bird population. But we have also seen multiple introductions of the virus through the Atlantic and the Pacific flyway, as you can see on this slide. However, most of our domestic birds were infected with the fully Eurasian lineage that was initially introduced in November 2021. And then another interesting finding was that we also have detected HPAI H5N5 in Atlantic provinces in the past year. And recently, the virus was also detected in Quebec. So the virus seems to be quite impactful on the wild bird population in the sense that all the birds and all the mammals that were infected with H5N1 were found dead. So it looks like it's very virulent. However, it's not progressing very fast. So we'll keep an eye on the progression of that virus, but so far it's been limited to Eastern Canada. When we look at the number of detections in wild birds, you can see the distinction between 2022 and 2023. And as you can see, 2022 was greatly impactful on the wild bird population. So we had over 1,600 detections in wild birds, mostly H5N1. And what you can see on the map represents the different reassortments that we have detected. When we compare with 2023, we had a significant reduction in the number of detections. Again, most of the detections were H5N1, but as I mentioned, H5N5 was also present. in Atlantic provinces. So as of last Friday, I did the extraction on this dashboard that is publicly available. If you want to play with the data, there are different filters. You can extract the data as well. So in 2024, so far, we're almost up to 100 detections. So it's slowing down in the wild bird population. However, it doesn't mean the virus is no longer present. It only means that wild birds are less impacted by the disease and are less likely to die, so we're not detecting the virus as much as before. But again, it may be suggesting that the infectious pressure in the wild bird population is decreasing. Mammals were also impacted by HPEI. Most of them were exposed to the virus by eating contaminated wild birds or by being exposed to a contaminated environment. Most of our detections, again, were with H5N1, but we have seen a few detections with H5N5. This is of importance because most of those animals are sharing similar receptors as human. So we're looking into the genetic of the virus when we're detecting infected mammals because we want to identify potential mutations that could increase the likelihood of transmission between mammals, but also increase the potential for infecting humans. So this is really a One Health issue that public health authorities are also keeping an eye on. I thought at this point it would be important to cover the livestock situation in the US. So I tried to summarize what was going on in the US. So late February, there was a first detection in goats, so HPAI in goats, because they were exposed to a backyard flock that was infected with dogs and chickens. And they were sharing a common environment, and goats were drinking in the pond where the dogs were. So not too surprising that they got the infection, but it's the first time we're seeing goats being infected by HPEI. Late March, there was a first detection in a dairy herd. And it has been an evolving situation. As of last Friday, there were 69 infected herds in 9 states, as you can see on the map, the states that are impacted by HPEI. But today they have announced that they have more cases now, so I think they're up to 80. So it is something evolving rapidly. Based on the information we know from a genetic and from an epidemiological point of view, we're suspecting that there was a single introduction in a farm in Texas, and then there were spread of the virus between farms by moving cattle. Within a farm, we think that cow-to-cow transmission is occurring likely through milking. HPI is highly impacting milk production, and the virus is highly concentrated in milk. Why is it of importance for the poultry industry? The US reported that there were multiple transmissions between infected cattle to egg layer farms. So we've been informed of 4, but there's likely more. The recent cases, we don't have a lot of information as of now, but it should be coming shortly. So for one of the infected egg layer farm, the US reported that there was sharing of employees and equipment between the dairy, cattle, and the birds. So it's likely a good way to transmit the disease. So far, the genotype that was found in cattle is very specific to cattle or to birds that were in the surrounding of those dairy cattle farms, but we have not detected this genotype yet in our wild bird population in Canada. Last week, there was also another new detection in alpacas with being positive for the same genotype that is circulating in the dairy herds, but it was following a detection on a poultry premises. So again, it is a dynamic situation, and we need to keep an eye on what's coming up next for us. When we look at all the detections in domestic birds that started in December 2021, we're now up to 422 infected premises with H5N1. So the graph is showing the epidemiological curve, the number of detections by province. So you can see the breakdown by years. So obviously it is decreasing significantly, but we do still have a few detections going on. So most of our infections were in commercial flocks. Over 11 million birds were impacted by the disease. When we look at the waves, it is somewhat following the waterfowl migration seasons. So spring, and fall again. However, there were some detections in between, for example, in Quebec in the middle of the summer. So we know that waterfowl migration is likely a higher risk period because waterfowl is the reservoir of the disease. BC is represented by the yellow color on the graph, and we see that it was the most impacted province with almost 40% of all infected premises. When we compare 2023 to 2022, we can see a significant reduction in the number of cases, so over 50% of reduction, which is a good sign that infectious pressure is being reduced, but the virus is still circulating. Overall, when we look at all the commercial infected premises, we do see an overrepresentation of turkeys and ducks. We did have a few infected premises that were infected more than once. So 26 infected premises were infected more than once, and 60% of them were turkey farms. So we'll be covering a few details later in the presentation on why ducks and turkeys are more impacted. But to start with, those two species are more susceptible to the disease. For example, turkeys, they do need a very low viral load to be infected. So any biosecurity breach would lead likely to an introduction of the virus. When we look at Canada at the international level, we can see here on the graph the top 10 countries most impacted by HPAI in 2022. So we can see that Canada ranks third on the scale, followed by just after France and the United States. And please pay attention to the scale of the graph because 2023 there was a significant reduction for all countries. So Canada is being in the fourth position here. And what we can see in 2023 is that there was a geographical expansion of the virus with more detections, for example, in South America. So we'll see in 2023, I was planning to extract the data in a month or so to assess where we are for this year. So let's focus now on the outbreak investigations on the 322 infected premises between December 2021 and September 2023. So this analysis is simplified for this presentation, but we're combining the genetic information, so the virus, the type of virus that was present on the farm, as well as combining the epidemiological investigation that we have done on each infected premises. So the questions we're trying to answer are infected premises connected? So is it farm-to-farm transmission, or it would be independent introductions? And what are the likely routes of introduction and potential risk factors? So to simplify the outcome of those outbreak investigations, by combining the genetic and epidemiological information, we are coming up with three different options. The first one would be independent introductions. That means that a farm was infected by being in contact, direct or indirect, with contaminated wild birds, but there was no further spread to another farm. So independent introduction. The second situation would be we have an initial introduction through a direct or indirect contact with wild birds, and we're seeing transmission to significant epidemiological link to another farm. So we're talking about a lateral spread in that case. The third option would be proximity or local spread. So that means that we did not identify an epidemiological link, or the link was missing during the interview. Or it could be as well that the farms are located in the same area and they're not independent because they're sharing a common wildlife population. So let's start by the results in backyard flocks. So the outbreak investigation conclusions for those a little bit more than 100 backyard flocks was that they mostly had independent introduction without a lot of surprise here. So most of them had outdoor access. So this is increasing the likelihood of being in contact with the virus. We did see one event of lateral spread, and it was through an auction that occurred in Ontario. So IP 31 participated to an auction with birds that were incubating the disease. And the birds were sold to different farms in Quebec and in Ontario that led to multiple other infections. So this is a way of presenting the phylogenetic analysis. It is showing the proximity, the genetic proximity between viruses found on those IPs. Looking now at commercial farms, so this investigation is focusing on 219 commercial farms. And again, we did see a lot of variation across the country. So approximately 39% were independent introductions. Local spread was seen in 30% of cases and lateral spread in another 30%. However, you will see on the next slide that there were significant difference between provinces. In most cases, we're thinking about a biosecurity breach. So birds were mostly kept indoors, but again, if the virus is present in the farm environment, there's a need to have a biosecurity breach to enter. For 50% of secondary cases, so the column you're seeing here, we have concluded that the likely source of introduction was the sharing of employees and equipment. Other routes of transmissions were shared service providers with direct contact with birds and movement of live birds. So here we're seeing provincial differences. So in blue, you would see independent introductions. In orange, local spread, and in gray, you will see lateral spread. So for example, if we look at BC, most of the conclusions were local spread. And as you know, BC in the Fraser Valley, the farm density is pretty high. So not too surprisingly that the farms were not necessarily connected, but they're likely sharing a common contaminated environment that led to multiple introductions of the virus. In Alberta and Saskatchewan, the situation was different, and it's likely due or related to the distribution of the industry and the practices on those farms. So most of the conclusions were independent introductions. In Manitoba, we have seen a variety of situation. Before the IPs that were involved in lateral spread, we're seeing one group of farm that would be a layer farms, and another group of farms that were connected together that were turkey farms. Ontario and Quebec, we're seeing a lot of lateral spread, but you may recall that Ontario and Quebec do have a lot of duck networks, and all of them were quite connected between them. So this is why we're seeing these graphs. So if we split out the commercial farms, but those that are supply managed compared to those that are not supply managed to try to see where are the differences, again, we see that supply managed farms, the conclusions are a bit different than what we have seen on the previous slide. So most of them were independent introductions followed by local spread and then lateral spread. However, when we see the non-supply managed farms that are commercial, so game birds or ducks and geese, we would see much more evidence of lateral spread. And that's just because how they were connected together. So at the bottom of the slide, you're seeing what's the likely route of secondary cases for lateral spread. So you can see that for supply managed farms, the most common reason was shared service providers with people getting in contact with the birds. So for example, a vaccination crew, inseminators, cell person, and so on. However, for non-supply managed farms, we're seeing the main routes of secondary cases would be sharing of employees and equipment. So when we look at risk now, so I will give you a few examples of what we think would be potential risk factors. We just need to keep in mind that we're saying potential risk factors because we don't have the negative farms to compare with. So this is another type of research that is ongoing that I will be covering later in the presentation. So the farm environment may be impacting the likelihood of being exposed to the virus. So if you're located near a wetland area, it is likely attracting waterfowl, for example. And depending on the season, the virus can survive in the farm environment. And if there's a biosecurity issue, then you're likely to introduce the virus. So most backyard flocks were located near a wetland area. And as most backyard flocks did have outdoor access, that's a good way to have a perfect combination for an infection. There are also farm practices that we need to keep in mind that could be attracting wild birds. For example, if you're removing carcasses outside but leaving them for a few hours before disposing to the final destination, that's an issue because it is attracting wild birds such as scavenger birds that may be impacted as well by HPAI. This is a nice video available on YouTube, and you will have the link in the presentation, but it's just showing a compost site and all the animals that went overnight. So raccoons, skunks, foxes, cats, and so on. So we're likely underestimating the risk that those mammals may play in transmitting the disease. Building manure pile near your barn is also a potential risk factor because it is attracting wild birds. There's feed left in the manure in the litter, and it is attracting birds. And if you're leaving the piles unprotected for several days, that's likely an issue when removing that manure pile. Feed spillage is obviously attracting wild birds, so we need to pay attention. We can see in the snow here all the traces from wild birds going around. I mentioned previously that backyard flocks, most of them had outdoor access, but we have seen also outdoor access on commercial farms. For 16 of them, some birds had outdoor access, which again it is increasing the risk for the birds on this site. 7 of them were supply managed, but the interesting thing is that there was a small group of birds, so ducks and geese, having outdoor access. So if the introduction of the virus goes through these birds, and then depending on how the other birds are being managed on the farm, it is a risk for the remaining birds to get the infection. So what you're seeing on the graph is the location of those IPs that did have supply managed birds as well as duck and geese with outdoor access. So we'll see with epidemiological studies if having multiple species on site is a potential risk factor. Barn integrity is also important. We have seen a few cases where wild birds did have access to the barns, or that we're suspecting they had access to the barn. So I'll show you a few examples here. So this is a turkey farm. This is the grow out section here with natural ventilation. And when we did the on-farm visit, it was somewhat surprising that there was no protection for birds in the chimney. And at this time of the year, the chimney would be open. So the farm manager did share this picture. So we're seeing a lot of blackbirds in that heat source. So it's a potential way of introducing the virus. In other cases was dead birds that were found in the ventilation system. So if you're having breaches or the barn integrity is compromised, birds can come very close to your domestic birds, and they can transmit the disease. Here we have found that pigeons were present in the ventilation, and based on the experience in the US with dairy cattle, pigeons can be impacted by HPAI. It's usually not a species that the wild folks would be sampling, so we don't know how widely they are impacted by HPAI, but it's likely the case. And oops, sorry. And if you do have areas where birds can nest, so we see here again, birds laying just beside the ventilation system. So again, this is too much proximity for HPAI. Another way of increasing the risk is to have an increased contact with the contaminated environment. So here the example I'm giving is the multi-age barn. So this is typically seen in turkeys, in ducks as well, and chicken could be as well, another example. So the issue is that when you're emptying a section while live birds remain in the barn, it's an opportunity for cross-contaminations. For example, if you're removing litter, doing in and out of the barn, you're maybe introducing the virus through the wheels of the tractor. And typically, the section may not be always clean and disinfected. If the dry cleaning is the industry standard, then you may not address the risk, the survival risk of the virus. Similarly, if you're doing partial depopulation or thinning, that's also a good way of introducing the virus. So those two factors are known risk factors for other infectious diseases. We'll see if it's the case for avian influenza. So if you're sending birds in multiple batches, and birds remain in the barn with sufficient time to develop the disease. And in addition, if you have limited or a lack of hygiene measures for catching crew members, or if you're not cleaning the side doors where the birds would be moved or people would be moving in and out of the barn to do that catching activity, it is a potential risk of introducing the virus and exposing the birds to the disease. Movement of birds between barns was also seen quite often in the turkey and the duck industry. So again, perhaps some of the factors are more likely to occur in some species. This is something we're going to be investigating with case control studies. So moving birds between barns, usually it's done using equipment. The equipment is often stored outside. It may be difficult to clean and disinfect, so it is a good way to expose the birds to a contaminated environment. So we need cleaning and disinfection procedures and catching procedures as well. Reusing litter is done quite often in turkey and in ducks, in breeder ducks as well. So typically the litter would be kept for a year, and some producers would be adding bedding mid-cycle. So it may or not be an issue depending on how it's done and if the bedding is stored properly without access to wildlife. Some producers are also removing part of the litter or adding a little bit at the end for the next cycle, but that's also an issue because it's difficult to manage the cleaning and disinfection of the tractor. In general, if there's a lack of separation between what's clean and what's contaminated, it is a good way of doing cross-contamination. So for example, as you know, seed and harvest season is overlapping with bird migration. So we're expecting that the fields would be contaminated if the tractor or the equipment going in the field is coming back to the poultry farm without cleaning and disinfection procedures, or if the producer repairs something during the seed and harvest seasons and come back and take care of the birds without changing clothing or footwear, it is a way of introducing the virus. Sharing of employees between farms was also seen. It's not necessarily an issue, but if there's no farm dedicated clothing, there's an increased likelihood of contaminating the vehicles. And finally, the traffic flow on the farm. This is a picture from ECMA in Quebec. So if you're having a clean road for the clean stuff, so feed, hatchery, clean litter, and a dirty road for what's dirty, so manure, renderer, and so on, it is a good management to avoid cross-contamination. So without any surprises, biosecurity is the main key to fight this disease. There are multiple technologies available for wild bird deterrence. So a laser could be used, sound, reflective kit, and so on. So something to look for, what's the best solution for the producer. Reducing contact with wild birds, we have seen several examples in the previous slides. So making sure that dead stock management is done properly, that feed is properly managed as well. But keeping in mind that if you're removing the manure, if wild birds had access to the manure, and then you're loading the manure a few days later, it is creating a lot of dust that can blow into the barn and infect the birds. because the virus can survive in dust depending on the outside temperature. So adding water on top of the manure pile could be a good way to manage this risk by removing that dust situation. Producers will need to inspect their barns as well, make sure they are wild bird proof, that there's no nesting possible, and that water infiltration is also not possible. We know that the virus likes humidity and cold temperature. So the virus can survive in snow, for example. So if snow is melting and the barn door it looks like this, water can be in contact with birds. We need to facilitate compliance. This is a well-designed barn entrance that is being secured, so locked all the time. There's a dirty area and a clean area delimited by a bench, so increasing compliance with hygiene measures. Having a broom specific to dirty area, another one for the clean area. So trying to keep that separate and keep the integrity of those two areas is very important, because the barn entrance is a critical control point. Footbaths at this stage are not recommended because they're not properly used. So most producers would not be cleaning their footwear before stepping into the footbath. The contact time is likely not enough to get the proper disinfection. So I do recommend to have really a distinction or keep an integrity of the areas within the barn. We need to make sure that the efforts that are done by the producers to increase biosecurity results in expected results. So for example, multiple producers did add multiple layers of protection. So for example, donning plastic boots while getting into the barn and then changing completely the boots while crossing the hygiene barriers such as the bench. This is a good way of having another layer of protection during migration season, for example. However, when we do the interviews with employees, they're saying that they are reusing plastic boots, which is not the best solution. So perhaps we could be thinking about other type of boots that would create less risk. So in conclusions, CFIA will keep monitoring the virus introductions and evolution and all the mutations that we're finding, for example, in mammals, because it is informing the public health authorities as well. Wild bird surveillance is an important early warning system. However, we're seeing less birds dying of the disease. It seems to indicate that there's a reduced infectious pressure. However, so far it's been going well during the spring migration, but the US, they're seeing a lot of cases right now. But it may be related to the dairy situation. Outdoor access is the likely main route of exposure for backyard flocks. We have seen limited farm-to-farm transmission, with the exception of that auction situation. And there's no transmission to commercial farms, which is a good thing. It seems that the two populations are distinct. Biosecurity failures were observed on commercial farms, but they were also influenced by environmental factors, distribution of the industry, and on-farm practices that may be increasing the risk of exposure. Farm-to-farm transmission was seen by shared employees, visitors, and equipment. So as you know, biosecurity is a continuous process. It is the key for preventing HPAI. So doing an assessment of the risk that is specific to the producer is very important. Selecting the mitigation factors that would influence or that would address those risks is important. Producers need to set expectations and communicate that to their employees so we can all have a good understanding of what's being asked. The main issue is likely how to evaluate implementation, how to evaluate that people are adopting those biosecurity measures and they do comply with it. So that's an area of interest for sure. So we can apply corrective measures and reassess the risk accordingly. So a few points here on EPI research that I'm aware of and that CFIA is involved in. So I presented in the presentation potential risk factors that needs to be confirm with case control studies. So we need to compare with negative farms to see what makes the difference, why they remain negative compared to the positive cases. So we're almost done with the turkey data collection in Quebec that was financed by MAPAC, and I'll have preliminary results to share on the next slide. The turkey study in Ontario is just starting. So the student was recruited and started a few weeks ago. There's also a case control study going on with the University of Calgary that is just starting. The other project that is starting as well this summer is that MAPAC asked for an assessment of the biosecurity measures in ducks and geese. So there will be a benchmarking study starting as of now. So for those studies, we're using a biocheck questionnaire, which is a publicly available questionnaire that was developed by researchers in Belgium. It is a well-known questionnaire. The interesting thing is that there's a scoring system associated with the questionnaire, so you can compare yourself with other at the international level, but you can compare, we'll be able to compare cases in positive and negative farms. The other project that is quite interesting is to have a better understanding of the interface between wildlife and farms. So this is a project that is ongoing in Ontario. So it is a prospective study. So we're investigating the likely source of introduction of the virus by sampling wild birds, mammals, doing environmental sampling so we can have a better understanding of where the virus is. So far there was one farm that was fully investigated, but we'll see with the next migration season if we have additional cases. So if we look quickly at the preliminary results, so I was just interested in presenting a quick overview of what the study looks like in turkeys in Quebec. So more results to come because this is only a few cases that were centralized in the database. There are others coming up. What we can see here is that I did extract the biosecurity score based on biocheck for the section on removal of turkeys. We see that the infected premises had a lower biosecurity score compared to the control farms, which are the negative farms. And when we look more specifically within that section, we can see that there's one question that was related to how birds were shipped to slaughter, if they were shipped in multiple batches or if they were doing all in, all out. So again, the proportion of farms that were infected were shipping birds in multiple batches compared to control farms or negative farms where the proportion is significantly is really lower. So we'll see if that is significant with all the other questionnaires coming up. But again, it is somewhat supporting what our thoughts were related to partial depopulation. Another question that was added to the biocheck questionnaire, it was related to movement of birds within the premises. So this question was not included in biocheck, but we were interested in having a better understanding of that potential risk factor because we have seen issues with infected premises. So again, the proportion of farms that were infected or more likely to do or to move turkeys between barn compared to the negative farms where that proportion is quite lower. So again, more to come over the next few weeks. We're completing that assessment for Quebec, and at the end of the summer, we'll be doing a similar thing for Ontario. So I'll stop here to see if there are any questions. Thank you for your participation.